Alright, in this video we're going to look at performing a task that we had done back in section 5.3 where we switched from standard form to vertex form. Now when we were in section 5.3 we had covered vertex form and standard form, and we said that if we had an equation that was in standard form, we could find the vertex by finding the x-coordinate by doing opposite of b over 2a, and then finding the y-coordinate by plugging back in for the vertex. Okay? So we did that process in these examples here, where this was our standard form. So we found the vertex doing opposite of b over 2 times a, and we found the x-coordinate, which was our h value, as 1. Then we plugged that back in and we found the y-coordinate, and we were able to locate the vertex that was at 1, 0. And then we knew our a, h, and k, so we were able to then, our a was 3, our h was 1, and our k was 0. So we wrote that using vertex form. We're just replacing a, h, and k. Well, now what we're going to do is we're going to use this alternative method that we just learned yesterday, called completing the square, to do the same thing. And I'm going to be taking you through these steps. These look a little complicated, but when you do an actual problem, they're actually not so bad. So let's look at a problem. Okay? Here's an equation that's in standard form. Now we'd like to put it into vertex form. Okay? It's currently in standard form. We want to put it in vertex form. Now notice that vertex form has a binomial squared. And in yesterday's notes, we learned how to put an equation into a binomial squared by a process called completing the square, where we came up with that third term and it turned into the same binomial, so we just wrote that squared. Okay? So here, if we want to get a binomial squared, we can complete the square. So let's try this. So the first step is going to be making sure the equation's in standard form. So this is a little different from yesterday. We want the equation in standard form, ax squared plus bx plus c. And our equation's in that format currently. Then, if you have a number for a out in front other than 1, you're going to need to factor that out. Because recall that the a in vertex form is the same a as standard form. So we would need to factor that out. Okay? So in this case it's 1, so we don't need to really factor it out, but I'm going to anyhow, just to show you that process. So we're going to take the a out, and then in parentheses we're just going to list the x squared in the x term. So this is going to be x squared plus 6x. Then I'm going to leave a gap because we're going to come up with that third term, and then I'm going to write the plus 5 on the outside of the parentheses. Okay? So now we're starting to get it into this format. Okay? Now, if we redistribute this, 1 times x squared is x squared, 1 times 6x is 6x. Okay? So if I were to just distribute the 1, drop the parentheses, I'd be right back to where I started. Okay? But I don't want to do that. I want to come up with this third term. So now I'm going to go ahead and complete the square. So I'm going to come up with this third term. So this is going to be half of the middle term, which is 6, which gets me 3. And then I'm going to square that, and that's going to turn into a 9. Okay? So this is going to be a plus 9. Okay? And let me write that in a different color. This is going to be a plus 9. Okay? Now, normally you would say, okay, well now I need to add 9 to the other side of the equation. Well, first of all, I need to make sure that that's still a 9. Because remember, this 1 gets multiplied by everything in there. So this is 1 times x squared, which is x squared, 1 times 6x, which is 6x, but then this is 1 times 9, positive 9, which is a positive 9. Okay? So, technically, I should add 9 to the left-hand side of the equation. But I don't want to, because remember, in standard form, this is y equals, and in vertex form, this is y equals. So I want to leave this side as y. So if I wanted to bring this plus 9 back to the other side of the equation, you'd have to do the opposite operation. So I'm going to get rid of it on this side, and I'm going to subtract it on that side. So this positive 9 got compensated with a minus 9. Now, we're all ready to put it in our final format, in vertex form. Look what happens here. Y equals, we're going to have this 1, that's our A. This trinomial here factors as a perfect square trinomial. First term here has to multiply together to get you x squared. This times itself gets you x squared. Since your signs are both positive, this is plus. And then what times itself gets you 9? This is 3. Now, on the outside here, we just got 5 minus 9. I know that. That's minus 4. Well, look. This is vertex form. We've got our A, our H, and our K. So this is your final vertex form. If you wanted to know your vertex is the point -3, -4. Because remember, the x is opposite, the y value is the same. So we were able to just find our vertex without having to do all the work that we had to do in section 5.3. We had to do an opposite of b over 2a and then plug back in to find your vertex. We just found our vertex by this process of called completing the square. Okay? So in the next video, we'll do a couple more examples.